Okay, this is our warm-up. It's actually also a review of Polygon Sums. So main things we need to remember is angles in a triangle add up to 180 degrees. So 180 degrees triangle sums. Polygon sums, n minus 2 by 180 for inside polygon. And for regular polygons, n minus 2 times 180 divided by n for each angle measure. So those are our basic formulas. Other things, parallel lines cut by transversal. We got alternate interior angles, corresponding angles, and same side interior angles supplementary. Okay, so let's see what we got. So looking at number 1 here, first thing I notice is that this is an isosceles triangle. We've got a 26. These two angles have to be congruent because those are base angles in an isosceles triangle. 180 take away 26 equals 154. Divided by 2, since these are two congruent angles, we get 77. So A is 77 and B is 77. So we got those. Well, A is not 77. The adjacent angle to A is 77. The adjacent angle to B is 77. Now, since these are a linear pair, so we also have linear pairs. Because these are a linear pair, 180 take away 77 gives 103. So angle A is 103 and angle B is 103. Over here, 180 take away, here's another linear pair, 180 take away 97 is going to be 83. So we got that. So that's all we can get out of this run. Let's look and see what else we can do. Now we notice that there are parallel lines. This line and this line are parallel. So parallel lines cut by transversal, if we do this Z pattern here, alternate interior angles are congruent. Angle C and 97 are alternate interior angles with each other. Angle C must also be 97 degrees. So we got 97 there. So what that does is that leaves angle E. So we could do, since we have 5 sides, we have 540 degrees inside this polygon. We could add all these angle measures that we know and subtract from 540, and what's left over will give us the measure of angle C. Now, there's another way that I came across last class. Again, if we use these parallel lines and use this as the transversal now, if we look at this 26 and we look at this angle here, these are corresponding angles. They're both to the right of the transversal line. They're both above the parallel lines. So this angle up here needs to be 26 degrees because it needs its corresponding angle. And then by linear pairs, we can figure out that angle E is going to be 154 degrees because 154 and 26 needs to add to be 180. So that's another way we could do that. So the end of this is add up all the angles, subtract from 540, gives you the one that's left. Or seeing that you got parallel lines here, you can do corresponding angles and get that measured that way. Okay, let's look at number 4. For number 4, if I go for vertical angles, I can throw an 85-degree angle down there. If I go with vertical angles here, I can throw a 44-degree angle over there, and took care of all the things we can do with vertical angles. I notice that this is an isosceles triangle down here at the bottom with this angle A as the vertex, but congruent base angles means that this has to be 44 degrees there, Both these add up to 88. If I do 180, take away 88, I get 92. So angle A is going to be 92. Trying to see what else we got. Here we can get angle C. We've got an 85 and a 44. That's 129. 129 from 180 gives me 51 degrees. So C is 51. So we got that one. Okay, let's see what we can do now. I've used up those. Let's look at the parallel lines now and see what we have going on with the parallel lines. So if I, say, use these double mark parallel lines here, this line and this line as parallel to each other, with this being the transversal, this 92-degree angle here goes up here because these are corresponding positions. So I can jump this 92-degree angle measure up to there. Okay, don't see anything else I can do with that transversal. Let's look over here at this transversal with these parallel lines. So we're looking at this one here. Comes down through here. This is an 85-degree angle here, which is to the right and below. So to the right and below we have angle D, which must also be 85 degrees since it's in a corresponding position with that 85. So we've got that. And what else we got? That's all I can see with those. We're still trying to get over here to E. We've got another set of parallel lines here. Let me do these in green. So this line and this line are parallel with each other. And let's see, if we go with this angle here, which is to the left and below, up here to the left and below, we have angle E, which is a corresponding position. And this must also be 44 degrees. So we've completely solved this diagram for all the missing measures. Okay, let's look at number 6. We're talking about exterior angles. And if I just draw a quadrilateral here, notice I can kind of continue this pattern like this, or I could draw the quadrilateral and go this way. The point is, exterior angles, one at each vertex, as you go in some kind of like a clockwise or counterclockwise direction around the figure, these angles all add up to 360 degrees, regardless of the number of sides that the polygon has. So all of these have to add up to 360. Now the other key word here is this regular polygon idea. That means all of these angles in the polygon. Now I'm not sure it's exactly this shape. I'm just using this for reference. But all of these angles need to be congruent if it's regular. So this rectangle or this parallelogram becomes more like a square with all equal angles. But what we need to see is that if this angle and this angle are all the same, these exterior angles, which are 180, take away the one that we know from the inside. These are all also going to be the same. So all these exterior angles are going to be the same. 4 sides, we have 4 angles. 5 sides, we have 5 angles, and so on. So this boils down to doing 360 divided by n, which is the number of sides, gave us 10 degrees. So a 10-degree angle came out of the exterior angles being divided by the number of sides that there were. And so we can reverse that by multiplying both sides by 10. We get 360 is equal to 10n. Divide by 10, n is equal to 36. So this is a 36gon. It's a 36-sided polygon. Has angles, exterior angles, that are 10 degrees. So we get number 7. It's the last one we'll do. So number 7, the sum of the measures of the interior angles of a regular polygon is 2340. Now it's a regular polygon again. That means all the angles are congruent. But it's asking us how many sides does the polygon have. So we need to find n using the formula n minus 2 times 180 equals the total number of degrees, which they're telling us is 2340. So I need to distribute, get rid of these parentheses, go over here with it. We have 180n minus 360, which is the 180 times minus 2, equals 2340. Add 360 to both sides, 180n equals 2700. Divide by 180, n equals 2700 over 180. Now I can take a 10 out of each one by knocking off a 0. So now I've got 270 over 18. 9 goes into 27 and 9 goes into 18. So 9 goes into 270 30 times. 9 goes into 18 twice. So now n is going to be 30 over 2, which is the same thing as 15. So this is a 15-gon that has the sum of angles coming out to be 2340. They could have easily asked us what each angle measured, and to do that, then we would do the 2340 total degrees divided by 15, and that would be what each regular interior angle had, with it being a regular figure. So again, to kind of recap, if you just need to know the number of sides of a polygon, n minus 2 times 180 is the formula. If you see something about angles in a regular polygon, it's n minus 2 times 180 divided by n. And if you see something about exterior angles, all the exterior angles, one at each vertex in a pattern, clockwise or counterclockwise, all add to 360 regardless of the number of sides.